So then the other set of loads going through the assembly are going to travel from that spherical bearing up through the tall knuckle up to this top spherical bearing holding the upper control arm. And there's a virtual line between these two pivot points. So as the bottom part of the wheel wants to move back as a result of hitting this bump, the top part of the wheel is going to want to rotate forward. And all of those stresses are imparted as a moment from this spherical bearing into the upper control arm. So what's interesting to me about this J-arm configuration that the trophy truck guys figured out, it's not obvious when you first look at it. I thought it was like a clearance thing. The back part of the lower control arm is thicker and the front part of the upper control arm is thicker because that's where the compressive load is. Whereas this part here is in tension, just like our suspension bridge. And this part of the J-arm is in compression from this pivot point to this rod end and from the same pivot point to this second rod end. So this helps constrain everything forward and backward as you hit a bump. Then the rest of the loads going up and down, the upper control arm doesn't experience any vertical load. Those are all absorbed by the lower control arm and imparted into the shock. The only vertical load on the lower control arm comes from this little sway bar mount here, which is not that much. It's just counteracting the roll force of the vehicle against itself. So I thought that would be an interesting explanation of load forces for you guys and how to trace them through a vehicle.